Hi everyone, another in our series of videos about solving systems. In this one we're just going to talk about equivalent equations in systems. So we're not going to actually solve any systems, we're just going to talk about what you can do to create a system that has the same solution as some other system. And so let's start off with equivalent equations though, so back it up a step to see if we can change an equation, at least the way it looks, and actually keep it fundamentally the same. So you can see this example that I've written out here. We've just got y equals 1/2 x minus 3. We're going to say an equation is equivalent if it produces the same graph. And so I think we have to go take a look at some graphs then. So I put on here y equals 1/2 x minus 3, just like we had in the example. And I also set up one with some sliders, where we're going to multiply the left-hand side by whatever the value of a is, and the right-hand side by whatever the value of b is. So you can see our equation here. Let me just change that value of a. Okay, now you can see that we're not getting the same graph anymore. See that orange line? That's changing the graph. So none of these are equivalent to the original graph, because they don't produce the same graph. So we don't have an equivalent equation at all here. So what do we need to do in order to have an equivalent equation? So let's say we multiply that by 5. Well, let's go to the other side, and we're just going to multiply that by something else. So if I go over here and I pick minus 8, I definitely don't get an equivalent equation. But if I go over here and I pick 5, on the other hand, well, let's say I could get it on 5. There's 5. Then you can tell that the orange line is falling right on top of that blue line. Okay, so what conclusion could we draw from that? Let's say we went to minus 6.7, and we try to do the same thing here. You can see once again we get that same equation. It doesn't matter what number you choose to multiply the right and the left by. As long as you choose the same number, you're going to get the same equation. And so that's what our goal is going to be next, is we're just going to go back there. We're going to pick some equivalent equations and write them out. So let's go back to that note there, and let's just talk about what we can do to create equivalent equations. So it says create 3 equivalent equations here. So what you can do here is you can multiply anything you like on the right and the left as long as it's the same number. So my first one I'm going to do here, I'm just going to multiply everything by 2. So 2x plus 3y is equal to, and again the right hand side has to be multiplied by the same thing. So I distribute into that bracket, and I get 4x plus 6y is equal to 18. So there's the first one. Second one, let's do minus 3. Okay, so it doesn't matter again what you choose. 3y equals 9 times minus 3. And I'll distribute on the left. I get minus 6x minus 9y is equal to minus 27. I'll leave the third one up to you, okay? Maybe try something fractional. Multiply everything by half or something. So that's how you create equivalent equations. You multiply or divide, because it's the same operation really, by the same on the right hand side and the left hand side. That's all it takes, and you've got it. Now, what we're going to do is we're going to look at 2 equations. And now these certainly are not equivalent equations. We do not have equivalent equations here. What we're going to do, though, is we're going to try to create an equivalent system. Okay, an equivalent system would have the same solution. Okay, same solution. And so what we're going to do here is just take these and we're going to add these equations together. So 2x plus x is 3x. 3y minus y is going to give us 2y. We have to minus because it's 3y plus. So plus minus y. And plus and minus give you plus equals 11. So now we've got these 3 equations. And what we're going to do is we have to graph all 3 of those equations.